good. I think we're good. You can see my screen. There we go. There, I see myself going. I want to make sure that I am going here. Get started. So this is about the play ball packet and what we kind of talked about, or at least I attempted to yesterday when I was talking to a gray screen. Make sure we're going. Looks like we're good. There, it looks like our audio is good. Cool. Awesome. Let's get this all off so we're not looking at that stuff. Hello. Hello again. If you're part two of this stream, here. So, yesterday, the little digital tool I went over to evidently to a gray screen, which is very disheartening, was talking about factoring. We're talking about factoring expressions. Factoring expressions. So say you had something along the lines of 4x plus 8. That is your expression. Remember, the expression part of that. What you're trying to basically find out is how many even groups you can create out of that. Now, those of you who saw my re-upload will also see that I used the digital tool to show that basically you're separating everything into into its own specific groups. So what you're trying to do, just to kind of review this a little bit, is that the first thing you do when you're trying to factor is you're trying to find what is the greatest common factor between 4x and 8. And really, here's a little tip. Don't worry about the x. Don't worry about the x when it comes to this. When you're coming to actually with factoring, don't worry about the x on this. So let's take that off. So your factors of 4, obviously 1, 2, 4. We usually skip 1 because 1 usually doesn't deal with that. So it's 2 and 4. So 4 has the factors of 2 and 4. 8 has the factors of 2, 4, and 8. So what is your greatest common factor? Your greatest common factor is going to be 4. 4. 4. So just in case you guys are looking at me on the screen, if I'm going back and forth, I am looking down at my phone right here to make sure I'm good with the audio and the video. What's up, Nick? What's up, Nick? How you doing, man? I'm just kind of going over what the gray screen that you guys saw yesterday. Just kind of going through this real quick. The 4. So 4 is the greatest common factor. You set your 4 outside of your parentheses. You set your 4 outside of your parentheses. And from there, you have to say to yourself, let me change the color. 4 times what is going to give you 4x? Well, 4 times x will give you 4x. So 4 times x will give you 4x. Bring down that same sign right there. And then I'll change the color again. So 4 times what is going to give you 8? Well, 4 times 2 will give you 8. So when you say, how do you factor something out? First thing you got to do is find your greatest common factor. Your greatest common factor for both of your terms right there. You find your greatest common factor. Let me get my screen clear here. So in the instance of 4x plus 8, you got to find your greatest common factor. Find your GCF, your greatest common factor first before doing anything. You do that, you set it outside of the parentheses. So set outside of the parentheses, set outside the parentheses, SOP, as we like to call that. And then number 3, backwards distributive. Backwards distributive. Sorry for my writing on that, but backwards distributive to be able to explain this part of this. You then say to yourself, well, what's 4 times what gives you 4x? It's x, and like we said, 4 times 2 will give you 8. So this, my friends, is your factored expression. So this is your factored expression. From here, I'm going to clear my screen. what I'm going to be going through here is the play ball. So the play ball packet, I don't know if you can see it on here, but it'll be the play ball packet. I believe that's what most of you have. If for some reason you have something else or you finished it or what have you, I believe I have my separate streams labeled to what I'm covering. Also, Ms. Holden's going over some of them too. So you have both of us to utilize through Google Classroom, through email, all that kind of good stuff while we're still under some form of a quarantine. Let's see what we can do here. Change this up. I'm going to bring up the play ball packet. That's not the play ball packet. Here we go. So I'm going to bring up the play ball packet. Now, I had a question about, let's see if I can find it here, was about the prime factorization. So it's about prime factorization. And it's talking about drawing factor trees. So I'm going to kind of spend a little bit of time going through this. I'm going to try to go through as much as I can. Will I go through everything? No. But hopefully get a couple of these pages to kind of explain what we're expecting you guys to kind of work on here. Kind of give a little bit of help. So again, prime factorization. Now, in my instance of writing on this screen, I'm going to be taking these questions, any questions, and kind of just writing to the side like I've been doing. It's very hard for me to write a factor tree in here, as you can see by my writing, so got to bear with me. So I'm going to be dealing with, let's deal with the number 15. So if you deal with the number 15, one second here. So if you deal with the number 15, let's look at the question. Let's look at the directions. It says factor trees can be used to find the prime factorization of any number. The following are examples of factor trees used to find the prime factorization of the number 18. So let's draw the factor tree to find the prime factorization. Prime factorization, prime numbers, prime factors of what you have there. It means you cannot break it down anymore. It's all the prime factors that multiply. So let's look at 15. Let's look at the number 15. Let me change the color. So 15. Now let's think about this. What numbers? So you have to ask yourself, well, what numbers can evenly be divided into 15? That can be evenly divided into 15. So you have to just start running through them, and you go, well, obviously 1, but you don't really count 1. 2, can 2 go into 15? No. Can 3? Well, 3, 6, 9, 12, 15. Yes, 3 can. So you say to yourself, well, 3 can go into 15 evenly, so 15 divided by 3 is 3, 6, 9, 12, and then 15. 3 times 5. That is all you need. That is all you need for this first question right here. It's 3 times 5. You cannot break down 5 or 3 anymore. You cannot break down 5 or 3 anymore on this. So if I were to zoom in real quick here. Let's zoom so I can kind of just make sure we're all on the same page. All on the same page. There we go. There we go. So for those of you looking at how to actually have this written down, maybe I can do this. 3 times 5, because that's how that should go. So just for the sake of this instance, I'm going to move to number 4. So I'm going to move to number 4. Let's look at the number 14. So can 14, what factors can evenly be divided into 14? It's the same process with everything. It's what factors can evenly go into 14. Well, you have to say to yourself, well, can 2 be divided into 14 evenly? Yeah, you see, well, 14 divided by 2, well, 14 divided by 2, 2 goes into 14 7 times. So 2 goes into 14 7 times. So you know that the prime factorization of 14 is 2 times 7. Can you break down Can you break down these anymore? Can you break down those factors anymore? No. So your final answer here is 2 times 7. 2 times 7. So now let's look at number 7. So I'm going to kind of move to the other side here too. So let's go out. I can clear the screen. Let's move to number 7 and let's change color. Let's move to number 7. Look at the number 25. So let's look at the number 25. What numbers, and it's this, again, it's the same process with this. It's what numbers can be divided into 25 evenly. So you start from 1, well, you start from 2, and you go, can 2 go into 25 evenly? No. Can 3 go into 25 evenly? Well, let's start thinking. 3, 6, 9, 12, 15, 18, 21, 24. No, it cannot. 4, no. Can 5? Yes. 5 can go into 25 evenly. So you say to yourself, and you say, is that Sienna I see on here? Well, hello, Sienna. How are you? So if you divide 5 into 25 evenly, well, you say 5 times what is 25? That's 5 times 5 is 25. Can you continue to break this down? The answer on that is no, 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 you cannot. So when 25 gets broken down into its prime factorization, it is simply 5 times 5. Exactly. You got it, man. You got it. So let's clear that screen and let's get down to a more difficult one. Let's see. Let's go to 80. Let's go to 80. Let's go to 80. Go to the number. Let me change the color again. So I'm going to go to the number. Let's go to, oh my, what the heck did I just do? There you go. If you're wondering this tool that I have, it's called Epic Pen. This tool that I have that I'm writing on my screen, it's called Epic Pen. It's free. The tool is actually pretty easy, easy thing to use. Gives you this nice little toolbar you can actually write on the screen. Kind of a cool little thing. Definitely helps to make it at least a little more interactive. So let's see. Let's take 80. Let's take 80. Let's take 80, and we start to break down 80 now. Now, let's start from 1. We'll start from 2 actually. Start from 2. So you start from 2 and you say, well, can 2 be divided into 80 evenly? And the answer on that is yes. You can divide 2 into 80 evenly. 80 divided by 2, so 80 divided by 2. 80 divided by 2 is, and to save you the time on that, is 40, because 40 times 2 is 80. So then you do the same process now with 40. So now you're looking at the number 40. So you say, well, what can go into 40 evenly? Well, can 2 go into 40 evenly? Yes. Yes, it can. So 2, and then what is half of 40? Well, half of 40 is 20. You then look at the number 20 and you say, well, what can go into 20 evenly? And I might run out of a little bit of room here. Can 2 go into 20 evenly? And the answer is yes. 2 times what's half of 20? That is 10. That's 10. And if I can somehow figure this out and write that, let's do this. Just so we have the full tree. We have the full tree going on here. 80 can break down into 2 times 40. 40 breaks down into 2 times 20. 20 breaks down into 2 times 10. And then 10, so there we go. So I'll kind of move the work up this way. So 10, you say to yourself, well, what can 10 be broken down into? And you say, well, can 2 go into 10? The answer on that is yes. 2 times, well, what is half of 10? Half of 10 is 5. And the question becomes, can you break down those terms or those values anymore? And the answer is no. No, you cannot. So this full tree that you see right here, so this full tree, I mean, is technically the answer you're supposed to be having put into here. Now, if we want to take this up a notch, let's do this. Let me get rid of some of this on this right side. So if you wanted to say to yourself and say, well, I mean, technically the prime factorization is 2 times 2 times 2 times 2 times 5. Well, instead of saying 2 times 2 times 2 times 2 times 5, if you're multiplying something by itself 4 times, wouldn't that be 2 to the 4th power times 5? 2 to the 4th power is 2 times 2 times 2 times 2, right? Yes. Yes. So 2 times 2 times 2 times 2 times 5 is the prime factorization. This is the prime factorization, and then put into more of a simplest term, a simplest form, would be that right there. So let's see here. I went with a little bit of time here. Let me clear my screen. Hope that helps a little bit. Again, prime factorization is nothing really totally difficult per se. It's just kind of finding the prime factors of each number. You know, you can get higher with like the number 196 or 212 and breaking it down that same way. And you say, well, what's the prime factorization of 3,420? And it's like, oh my goodness, you have to figure out everything. But let's see here. Let me clear my screen. I'm going to scroll to, just because I had talked about this, here we go. So here we go. I know I had a question about this, and I did post a couple videos. So I did post a couple videos about adding, subtracting, multiplying, dividing fractions. Check those out on our page here. I mean, I'll go through this real quick just because, like I said, I did create a couple videos about that. Let's take kind of in my opinion, the easier forms of this. If you had the fraction 6 over 5, so 6 over 5 divided by 2 over 3, and I'm kind of realizing now that that is too dark of a color. So let me change the color. Let me go here, and let's go 6 over 5. So 6 over 5 divided by 2 over 3. So when you are dividing, when you're dividing fractions, simply put, you're going to, if you remember this, keep, change, flip, not KFC, but KCF. You're going to keep 6 over 5. You're going to change the division sign to a multiplication sign, and then you're going to flip that second fraction to 3 over 2. And again, in my opinion, multiplying fractions are actually probably the easiest part of dealing with anything with fractions, because simply put, all you're doing is multiplying across. You're just multiplying across, which is kind of, I mean, to be totally frank, simplistic. 6 times 3 is 18. 5 times 2 is 10. And then you say to yourself, well, I have 18 over 10, and let's keep this up in the corner here just because I'm going to be scrolling down. 18 over 10, 18 over 10. I'm remembering that. You have the number 18 over 10. You got to say to yourself and look at your answers that you see down here, and you go, well, I don't see any fraction, any answer that is in its improper form, in the improper fraction here. So what we have to do is now change the fraction to a mixed number. So when we change a fraction to a mixed number, let's change the color. We're going to take our denominator, which is 10, and we're going to divide it into the numerator. of 18. So we say to ourselves, so we say to ourselves, 10 goes into 18 one time. 1 times 10 is 10. 18 minus 10 is 8. So 18 minus 10 is 8. And so that 8 becomes the numerator of your new mixed number. So you say to yourself, and you go, well, I have 1 and 8 tenths. So 1 and 8 tenths, and you say to yourself, well, do I see that answer down here? And the answer is no. You have to reduce this. You have to reduce that part of the fraction. What number goes into both 8 and 10 evenly? Well, take the first answer, and that is 2. So let me change the color one more time. We're going to reduce 8 over 10. We're going to reduce 8 over 10 to its simplest form. Well, what's 8 divided by 2? Let's get our mixed number, our whole number, our 1. 8 divided by 2 is 4. 10 divided by 2 is 5. 1 and 4/5 is your answer to its simplest form. I know it's a lot of oddball writing with the 18 over 10 over here and this going on over here, and I look like I'm drawing plays up, but 1 and 4/5. So 1 and 4/5, and whatever, I believe that was 6/5. Yeah, there we go. Let's do this. Let's get this off of here. There we go. So the answer to what is 6/5 divided by 2/3 is 1 and 4/5. 1 and 4/5. So the letter E goes right down there. Yes, chicken is good, yes. Let's see, what else can we do? Take an easy one here. Let's take an easy one. What's 1/3 plus 1/3? 1/3 plus 1/3. 1/3 plus 1/3. And let's get this off of here. When you're adding fractions, always make sure you have the same denominator. You have a common denominator. Now, this one right here for C, the letter C, the makers of this question were very nice to you guys. So when it comes to this, you have the same denominator. You still have a 3. So all you're really doing here is you're just adding across in the numerator. 1 plus 1 is 2. You keep that same denominator of 3. So your answer is 2/3. 2/3. That's a 2/3. So you look down here, and you see that 2/3 is right here. And C would be put right there. So let's see what else we got. Let's see what else we got. Do one more here. One more. Let's go all the way to the top. And this is going to be kind of what I was talking about in my other upload a few days ago there. 2/3. So 2/3 plus 3/4. So if I have 2/3 plus 3/4, so 2/3 plus 3/4, you have to first of all find what you would say would be the least common multiple of both denominators. So here's the thing. I usually will go by the instance of saying, let's take the 3 and let's just multiply by the 4. With these smaller numbers, you can do that. If you have numbers that are like 256 and then 17, then it becomes kind of odd figuring that out. But in this instance, you're trying to find the least common multiple of both 3 and 4. I mean, if you really wanted to, you can put a 3 over here and say, well, we got 3, 6, 9, 12. And then for 4, you would have 4, 8, and 12. Your least common multiple of 3 and 4 is going to be 12. It's going to be 12. It's going to be 12. So let's remember this up on the screen here. Your least common multiple. Least common multiple is 12. So let's go back to our problem. 2/3 plus 3/4. 2/3 plus 3/4. Our least common multiple is 12. So you say to yourself, 3 times what gives you 12? Well, 3 times we figured it was 4 gives us 12. What you do to the bottom, you're also going to do to the top. Well, what's 4 times 2? 4 times 2 is 8. 4 times what is 12? Well, that's 4 times we figured that was 3, obviously. What you do to the bottom, you do to the top. 3 times 3 is 9. And just like in our last little problem here, we have our same denominator. So the 12 will stay the same. 8 plus 9 will be 17. So is our answer 17 over 12? Well, that's the answer in the improper form, the improper fraction form. So if you remember 17 over 12, and let's actually scroll down a little bit. Let's clear the screen and scroll down. 17 over 12. Let's scroll to the bottom and look. And we need to turn that 17 over 12 to a mixed number. So what do we do? What do we do? What do we do? Oh my. I don't know why it does that. There we go. 17. Oh my goodness. There we go. 17 over 12. So 17 over 12, change to a mixed number. Take that denominator and divide into the numerator. So 12 goes into 17 one time. 1 times 12 is going to be 12. 17 minus 12 is going to be 5. That 5, let me get rid of this here. That 5 becomes the numerator of your new mixed number. You then bring this term over to be your denominator. So your answer to 2/3 plus 3/4, so your answer to 2/3 plus 3/4 is going to be 1 and 5/12. And you look down, you'll see 1 and 5/12 is right here. And that gets the letter, what is it? It's T. So that would get the letter T. 1 and 5/12 should get the letter T. Letter T. Hope it helps. Hope this helps. I'm going to do what I did here and sign off here in about a minute and then break into the yard sale packet, talk a little bit about that. With that being said, I hope this helps. Always reach out if there's any questions. Reach out via Google Classroom. Just know that with Google Classroom, there are these nice little apps that are on here that actually I can actually see all the posts that are coming on there, so I don't have to be in front of a computer. So with Google Classroom, it's very easy. That's why a lot of times with any posts that come in there, I can get back, pretty quick with that. So, but other than that, I'm going to pop back on here in about 2 minutes ish with the yard sale packet. We were talking about yesterday with 8th grade, the one stream that actually worked full-fledged yesterday. So with that being said, I will bid you another adieu and see you in about 2 minutes.